So welcome back. We're in our third video of chapter 4, and this is the stuff that I really find exciting and fun to do. So I'm really excited for today's video. So the data that we're given is from a marketing firm, and we are tracking sales of compression gear by age, where the consumer's under 35 or 35 years or older, and by brand. And so we're specifically going to be focusing on Under Armour here, and we're going to be looking at who is buying Under Armour gear and trying to figure out where we should direct our marketing. So this is a very real application of the way that we use statistics and probabilities, is we want to make sure that our marketing efforts are tailored towards the people that are buying our product the most or are the most likely to buy our products. So we want to examine this with other competitors and see if maybe, hey, maybe we can steal some of their consumers, or what do we need to do to get a bigger share of the pie. So we're looking at what we call a contingency table. So back in chapter 2, we talked about frequency distributions, and those are used for when we have qualitative data. So this is the same thing. We've still got some qualitative data here, but we're looking at two different variables that we'll categorize as X and Y, so to speak. And so each cell represents a different pair of X and Y variables. So in chapter 2, we were just looking at one variable, maybe it was age of consumer, but now we're looking at two, age of consumer and what brand did they buy. So we're going to set up our table with age being like the X. And so we've got two categories, under 35 and 35 or older. And then Y is going to be our brand name, which we have three categories. So first thing to note, you do not have to have the same number of categories in X and Y. It's perfectly acceptable to have different ones, different number of categories. So each cell in the table represents a frequency. So for example, we can see that 174 consumers purchased Under Armour and were under 35 years old. And then we can see that 54 consumers purchased Under Armour and were 35 years or older. Now, in order to calculate the relative frequencies, we want to calculate the total. So we've just added a column and added a row where we've calculated the total. So now we can see that 228 out of 600 consumers purchased Under Armour. We can see that 396 out of 600 consumers were under the age of 35. Now, I want to point out that a lot of times we're going to use variables in place of those labels that we had. It makes it a little easier when we're writing our formulas, especially when we're in a statistical program and we're trying to code this in. So just for reminder's sake, remember B1 is Under Armour, B2 was Nike, and B3 was Adidas. And then our ages here, A was less than 35, and a C, which is the complement of A, is everyone who is not under 35. So this would be everyone that is, I wrote those backwards, sorry. So the age is under 35, and then AC, the complement, is everyone who is greater than or equal to the age of 35. So again, we've got our totals, our row and our column totals, and then we've summed them, pardon me, and so we've got 600, which is exactly what we expect to have because we pulled 600 samples. So now, given this data, we can ask some questions. So what is the probability that a randomly selected customer is younger than 35 years old? So what we're really asking is, what is the probability of A? And so that would be 396 divided by my 600, my total. which it tells me it is 66%. So 66% of consumers were under the age of 35. So now my next question is, what is the probability that a randomly selected customer purchases an Under Armour garment? So that's going to look at here at B1. So 228 out of the total of 600 purchased Under Armour. So that's the probability of B1, which gives me 38%. So 66% of consumers, goodness, that's hard to say, were under the age of 35. 38% of all consumers purchased an Under Armour garment. All right. So now, what is the probability that a randomly selected customer is under the age of 35 and purchases an Under Armour garment? Okay. So now we're looking for that intersection of Under Armour and A, and under 35. So we're looking at 174 out of the 600 total consumers purchased Under Armour and were under the age of 35. So that is 29%. So this is what we call a joint probability table. And it can be very easy. It makes it a lot easier for us if we'll just go ahead, instead of putting the raw data there, we'll just go ahead and plug the probabilities in there. So we'll just divide each cell by the total. So we're going to divide each cell by 600. And then notice that our total column over here is 600 divided by 600, which gives us 1. So again, this is easy to create in Excel. You can plug your data in, you divide it all by the total, the grand total of 600 over here, and we've got our joint probability. Now notice that we've also divided the individual amounts. Those are what we call the joint probabilities. So those are the intersections. So for example, we could say how many consumers, or what's the probability that a consumer purchases Adidas and is 35 or older? Well, in that case, that would be 13% right here. So we can easily calculate those joint probabilities, or easily see those joint probabilities. We also have calculated what we call the marginal probabilities. Now the marginal probabilities are, again, those totals. So we can see that 34% of consumers were age 35 or older. 34% of consumers purchased a Nike product. We can easily see those marginal probabilities, and then the joint probabilities are the intersections there in the middle. So now let's go back and ask ourselves, what is the probability that a randomly selected customer is under 35 years of age or makes an Under Armour purchase? So not and, but or. So now we're looking for the union of A and B1. What is the or? So we're going to take all of A, so that's the 174 plus the 132 plus the 90. So all the consumers that were under 35. And we're going to take the consumers, all the other consumers that bought Under Armour. Okay, so we don't want to double count. I don't want to use the 396 and the 228 because that's going to double count those 174 consumers that were under 34 and purchased Under Armour. So you can take all of A plus the part of B that wasn't already included, or the other way you could do it is take all of B, let me do this in a different column, is take all of B plus that of A that wasn't included in B. But either way, we're going to divide it by 600, which is our total there, and we get 75%. So 75% of the consumers were under 35 or purchased an Under Armour garment. Now again, the other way that we learned in an earlier video is it's the probability of A plus the probability of B1 minus that intersection of A and B. So we'd already calculated the probability of A to be 66%. We had calculated the probability of B to be 38%, and we had calculated the intersection to be 29%. So when we divide that out, we still get, or add and subtract that out, we still get 75%. So lastly, we want to look at what is the probability that a randomly selected customer is under 35 given that they purchase an Under Armour garment. Okay, so we looked at this formula in the second video. So we're looking at the probability of A given B, which is the probability of the intersection of A and B, which is 174 divided by 600. We've already calculated that on a separate video. So 174 divided by 600 gives us that 0.29 divided by the probability of B, which is the 228 divided by the 600. So we get 76%. Now I want to point out the other way that we could look at that is we calculated the probability of A, the intersection of A and B, which we said was 174 over 600, and the probability of B, which was the 228 over 600. But notice in our formula now, the 600s actually cancel each other out. So we end up just asking ourselves, what is 174, the intersection of A and B, divided by B, 228? We still get 0.76. So notice how they cancel each other out. So when we have this contingency table here, really all we're saying is what is the probability that they're going to fall into this cell if they're in this column, which is just 174 divided by 228, or 0.76.